All right, so this is going to be our practice week, week one, for taking notes off of videos. From now on, after today, or after this video, you will be doing it on your own. All videos will be posted on Blackboard. That way, if you miss class or if you just need to go back and review or finish up some notes, you didn't get them done, you can always go back and do it. So this is a lesson from the algebra, so you should have seen it before. So remember, notes are part of the homework. So notes, these are the algebra notes, Module 3, Topic 2, I think actually Module 2, Topic 2, Lesson 3. All right, so you want to identify your notes on every single one, and we'll kind of talk about in class how to put the notes all together and that and where you need to keep your notes. But for right now, I would like you to work on this warm up. So go ahead and try numbers 1 through 4. If you get stuck, go ahead. It's been a summer, so just give it your best try. So again, these are notes for Algebra, Module 2, Topic 2, Lesson 3. And I want you working on the warm-up. So I'll give you about a minute, minute and a half. Some of you might be finishing up. Just sit quietly. Again, after this video, you'll be doing this on your own computer, so you can obviously skip ahead a little bit if you need to, but we got about 15 more seconds or so. Alrighty, so even if you aren't quite done, let's go ahead and check some answers. So you should have gotten, for number 1, x equals 5. Number 2, x is greater than 7. Number 3, x is less than or equal to -3. So notice I'm multiplying by a positive number, so the inequality symbol doesn't flip even though the answer is negative. And then for number 4, the inequality symbol does flip, so you should have gotten x is less than -4 because I'm dividing by a negative number. All right, so what I'd like you to do is we're going to kind of work through this lesson, taking notes. So I would like you to kind of read the situation and then answer number 1. So you're going to be writing a function. We're going to do it in slope-intercept form. So just a quick reminder there on slope-intercept that it is in the form of y equals mx plus b, where m is the slope, okay, or the rate that it either goes up or down by, and b is the y-intercept. It's basically where it starts. Okay. All right, and they do want you to write it in function notation, so it's the same setup, the y equals mx plus b, but it's just going to be with the f of x, or in this case f of b, because they want you to use b for the number of boxes of popcorn. All right, so it's going to be f of x is equal to mx plus b. So function notation just puts in that f of whatever variable you're doing in place of the y. So go ahead and give number 1 a try. See if you can write an equation that represents the situation for Alan's camping trip. Even if you're not sure, go ahead and just give it a try. See what you get. All right, so again, all right, we have a situation here where, okay, we have each camper starting with a credit of $25, and that may be a little confusing because credit, you sound like you're charging something, but actually in this case you're getting something. The camper is getting $25, so it's like they get a $25 start off. So they already have $25 in their sales. And then, all right, each box of popcorn sells for $3.75. Okay. So you should have a function. So in this case, again, they want us to use B for the number of boxes. So the rate that the amount of sales is going up by is $3.75. Okay, and each one starts with $25. Okay. All right. So then they ask us to analyze the function and identify the independent and dependent quantities. Let me see if I can get it done. There we go. So independent, the thing to think about independent is it's what drives the situation. In this case, it's the number of boxes sold. The dependent is the one that is the solution. So it's basically, it depends on the independent. So our independent number of boxes, our dependent is the total sales because the amount of sales depends on the number of boxes. Then they ask us to identify the slope. So remember, the slope is the number in front of the independent variable. In this case, our independent variable is the number of boxes, which is the B. So the 375 is in front of the B, and what it represents is the cost of one box, or the price of one box. Okay, and remember, slope does not include the variable, so it's not 3.75b, it's just the number in front of the variable. And the y-intercept is where it starts, so each camper started with $25, so it's the amount that Alan started with, which is 25. All right. Okay. All right, so we now have, we're going to move on to the next activity here. And this graph represents the function that we wrote. So this represents all the solutions when the function is true. So 3.75b plus 25 is equal to f of b. So that's all the sales. So they are asking us here, suppose Alan has a sales goal of 1,600. Draw a horizontal line from the y-axis until it intersects with the graphed function to determine the point on the graph that represents 1,600 in total sales. So basically, we just have to draw a horizontal line. So I am just going to draw a line here across, starting at 1,600 to where it intersects. Okay. All right. That's all you got to do on that one. Part B says, how many boxes would Alan have to sell to make 1,600 in total sales? So total sales is at this point right here. Of 1,600. Okay, that's where it intersects that line. So then we need to see how many boxes that he sells to reach that. So we are going to be looking down at how many boxes he sells right there. And in this case, They're going up by 60, so every 2 boxes is 120, so that means every 1 box or every 1 line is 60. So 360 plus 60 is 420. So that means that Alan would have to sell 420 boxes of popcorn. To make 1,600. Okay. All right. Now, how would we represent that on just a number line? Well, exactly 420. So we would put a dot right on 420 for number of boxes sold. All right, so now they ask us to analyze the region of the graph that lies below the horizontal line you drew, up to and including the point intersected in the line. So now again, we're looking at, okay, that lies below the horizontal line. So we're kind of looking at this area down in here. Okay. All right. Then they're asking, what does this region of the graph represent? Well, it represents all the boxes sold up to $1,600. So it's the total amount of boxes sold when the sales are less than or equal to 1,600. So notice they do state that up to and including the point. So it's up to or less than and equal to 1,600. Now, I want you to go ahead and try to write an inequality to represent this situation or this region. So basically, remember, you want to look at it in the number of boxes sold. So if we're looking at it from the number of boxes sold, it's going to be all the boxes that are less than or equal to 420. You could do it from the amount of sales, but the way that the book is leading us down, they want us to do it in the number of boxes. So it would be B is less than or equal to 420. And then the next thing they ask you to do is use the number line to represent the number of boxes that are solutions. So again, taking it from a graph into a number line, and it's going to look something like that. So we're going up to 420, except mine is off a little bit here, so let's fix that just a little bit. So 420 down, there we go. Okay. So number of boxes sold, and that's represented by the yellow region in the graph. Okay. All right. So now they ask us to, oh, first off, sorry. I think there's one more a little bit here. Where do all the solutions make sense in the context? No, because only the solutions on the line work in the context of the problem. You can't have half boxes sold. You can't have, 110 boxes sold. And I mean, it's just, so you can't represent all of them based on the context of the solution, if we're going to fit it in exactly how that is. Okay. Now, we're going to ask her, they're asking us to analyze the region of the graph that lies above the horizontal line. So now we're looking kind of at this purple region up here. Okay, but notice this time, now they are saying not including the point intersected by the line. So now we're not including it. So what does it represent? Come on, there we go. So it is the amount of boxes sold that earn total sales above $1,600. And again, we're writing it from the point of view of the boxes sold. So the inequality is going to be greater than 420. Notice we're not including it, so it's not equal to the number of boxes, the 420. And then an inequality on a number line like that would then be an open circle. And the arrow would be greater than 420. And again, they ask the question, do any of the solutions make sense? No, only the ones that are on the line can represent the situation. Okay, all right. So then I would like you to explain the difference between the open and closed circles on the number line, and I would like you to answer number 5. So you can work with a partner or on your own. You can use the graph to answer 5A, B, and C. I'll give you a minute or two, but again, number 4 and number 5, I want you to try on your own or with a person next to you. So you're going to explain the differences in the open and closed, and then use the graph to answer questions A, B, and C on number 5. So I'll give you a couple of minutes to do that. And for number 5, you might have to actually write an equation and actually solve for it. You may not be able to get the answer straight off of the graph. So you may have to go back to your original inequality or equation. Okay, give you about another minute. All right, so go ahead and check answers here. So the open dot or just the circle means that it does not include the solution. The closed dot means that it does include, that's nice, does include the solution. All right, and then for number 5, A, So how many boxes would Alan have to sell to earn at least $925? So remember, 925 represents the total amount of sales, or the F of B. So you would put in your equation 3.25B plus 25 is greater than or equal to 925. And so then B has to be greater than or equal to 240. So he would need exactly 240 to earn at least $925. To earn less than $2,050, again, you're going to be doing the 3.25B plus 25 is less than 2,050, and you can solve that, or you can kind of plug and chug some numbers there, and you would find out that he would have to sell less than 540. 540 would get him 2,050, so you would have to sell less than 540 boxes. And last but not least, to earn exactly 700, so that would be equal to 700, and that would be 180 boxes. All right, this wraps up our notes for our first little practice. Hope that you were able to get it. If you missed any of it, it is, again, I'll show you where it's going to be posted, but it's posted on Blackboard, and you can go back and review it. Thank you.